Guys, coming at you with an enthralling video about math. Here we're continuing the series in geometric proofs. This time we're talking about perpendicular lines. Just remember, proofs are very difficult, can take quite a while to get right. It involves logical thinking, and if you ask me, it's a skill that's seriously needed in this world. So let's just get to it. We're going to talk about congruency, we're going to talk about the definition of perpendicular, and then we're going to do two proofs. Alright, so first let's talk about congruency. Congruency just means when you have two objects that are exactly the same in geometry. It's different in the numerical value, so we're not talking about like 5 equals 5 here. We're saying this triangle monster is the same in every way as this triangle monster. It's a physical concept here, where it's exactly the same. Okay, let's take a look at how different triangles, or different ways we can prove that triangles are congruent. So I'm going to kind of blast through this real quick. We have side, 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 which proves two triangles are congruent when we have three pairs of sides that are congruent in both triangles. We have side, angle, side, when we have two pairs of sides and then a pair of angles that are included or in between two triangles, making those two triangles the same. We have angle, side, angle, where we have two pairs of angles and then we have a pair of sides included or in between two triangles and making them congruent. We have angle, angle, side, which is two pairs of angles, but the side is not included, and those triangles, making those triangles congruent. Then we have one we're going to focus on today, which is hypotenuse leg. And in this case, it's only good, useful for a right triangle, and it's when we have a hypotenuse and a leg that are congruent, but we also have to have a right angle present. Okay, let's take a look at what perpendicular means. So, the definition of perpendicular, it's a fancy word for just saying that lines that intersect to make a 90-degree angle. So when you have perpendicular lines, you're making a 90-degree angle. That's it. Okay? The word is sometimes more intimidating than the actual concept. So let's take a look at how we handle this. So the first proof. Okay, the first proof, I copied down the given already. And what it wants us to do, it wants us to prove that these two triangles are congruent. And what it gives us is that AB is perpendicular to DC. That's what that upside down T means. And AC is congruent to BC. Now, with these, we want to handle them a little bit differently than maybe other proofs, even though this is a tactic that works for any proof. I want to plan this out first and see how I'm going to prove the triangle is congruent before I get it to this table. So when I see that AB is perpendicular to DC, that means I'm going to have a right angle here and naturally here. Okay? I say naturally because this makes a straight line, right? And there's no indication, two reasons. There's no indication which side the right angle would be on based on this statement. And also, it's a straight line. And straight lines add up to 180. So, if one side is 90 degrees, that means the other side has to be 90 degrees. Now, it also states that AC is congruent to BC. So, AC is congruent to BC. Okay, then I have my reflexive side in the middle. Now, in this case, we're going to handle the perpendicular line slightly differently than we would in on maybe a different proof, because I'm going to go for HL here, right? So I'm going to say that these two triangles are congruent because of hypotenuse leg. So I have to use the perpendicular lines in a specific way for that matter. So let's get started. So first I'm going to get the reflexive side out of the way. And I'm going to write that in a different color. So I'm going to say DC is congruent to DC because of the reflexive property. Okay? Reflexive property. Okay, now let's handle these perpendicular lines. Well, as a result of this, I know that these are right angles. So what I'm going to say is that angle ADC and angle BDC are right angles. And that is a result of this. I know that because AB is perpendicular to DC. Now, from there, I can make the statement that these two triangles are right triangles. Remember, I'm dealing with hypotenuse leg here, form of congruency. So, as a result of that, I need to make the statement that these triangles are right triangles first. Then I can apply hypotenuse leg to it. So I'm going to say triangle ADC and triangle BDC are right triangles. And that's because of this statement. So now I'm going to have to fight my way with my left hand without smudging this whole thing by basically saying that these are right angles. And BDC are right angles. Now, this is kind of part of the nature of geometric proofs that I get to display here. We made a statement based on a previous statement. So I use this evidence to make this statement. Then I'm using this statement as evidence for the next one. So sometimes in definitely longer geometric proofs, you're going to kind of start getting this kind of zigzag repetitive nature. So next, from there, I can make the statement that triangle ADC is congruent to triangle BDC because of HL. Okay, so that's that proof. All right, let's take a look at another one. So, here's this one here. Slightly different. Again, I highly recommend that when you do these proofs, you plan this out ahead of time. So, it says here that AB is perpendicular to DC. I wrote that, I copied the given already. And again, that's going to give me a right angle here and here. Then it says that D is the midpoint of AB. So if D is the midpoint of AB, that means that this and this are congruent because of a midpoint. So that's happening because of a midpoint. I'm going to write that there for a note. Then, put an arrow here too. Then, I'm also going to say that I have DC is congruent to DC again because of the reflexive property. Okay, so let's handle this. So let's get rid of the midpoint and the reflexive property first. And again, it doesn't really matter what order I do this in. I'm doing it in this order just so then I can color code it and organize it for you guys. But if you wanted to handle the perpendicular lines first, you absolutely could. As long as you have all that all those statements down prior to proving the triangles are congruent. And in this case, I'm going to prove the triangles are congruent by side, angle, side. So let's take a look. Let's do the midpoint first. AD, line AD, is congruent to line DB because D is the midpoint. So I could say the property of a midpoint, or I could say D is the midpoint. However you want to handle that, D is the midpoint. Okay, next. I got the reflexive property, so I'm going to say DC is congruent to DC. And that's the reflexive property. Okay. And there's the trials and tribulations of being left-handed. Now let's handle these right angles. This time, I'm going to use side angle side. I'm not going to use HL. Even though I do have a right triangle, I don't have the hypotenuse here to prove congruent. I can't do it in any way that I know of, at least sitting here as the proof is now. So I'm going to go with side angle side. And again, just like last time, I'm going to make the statement that angle ADC and angle BDC are right angles. And that's because of this. Okay, that's because of the perpendicular lines. But now I'm going to use them as a congruent pair of angles, unlike before where I used them to state the triangles are right triangles. So I'm going to make the statement that angle ADC is congruent to angle BDC. And that's because of this. Right? So now I'm going to have to try to write that in there without smudging this proof up. So ADC and BDC are right angles. Okay. Now I can turn around and say, since I established that this is a congruent pair of angles and I have two congruent pairs of sides, I can make the statement that triangle ACD is congruent to triangle BCD by side angle side. And that is that, guys. This is the video for geometric proofs on perpendicular lines, on how to handle perpendicular lines. And I hope you guys found this video helpful.